Hello everyone, and welcome to the last BSG seminar of 2025. I think you'll all agree we've had a range of really exciting talks this year, and we've got many more planned for 2026. So please look out for them in the BSG emails and the newsletter if you're a member. If you're not a member, then please do consider joining. Obviously, these are open to everyone, but there are many more benefits of joining. Check out the website to see what membership can offer you. And it does include being on the mailing list, the direct mailing list for these seminars too. Just to make you aware that this seminar is being recorded and it will be put up on the BSG YouTube channel shortly following this talk, and it will be linked from the website as well. Please feel free to share the link afterwards if you think there'd be anyone who'd be interested in watching it. And yeah, well, this leads me to saying I'm really excited to welcome Martin Mergili from the University of Graz in Austria, who will be talking about the concept of geosystem services in environments shaped by landslides. If I could ask for everyone to stay on mute until the seminar ends, that would be really handy. But at that point, I'll open up the floor for questions. And so, yeah, I'll let you have control of unmuting and muting as you wish. Excellent. I'll pass over to you, Martin.
Okay, yeah, thanks a lot for the introduction, Nish, and welcome everyone to my talk today. So as you can already see with the title, so it's maybe a little bit of an unusual topic. Yeah, I will take you to today. So I'll talk about landslides as geosystem services. So landslides are usually, well, have a rather negative association, I would say, in society, but we'll try a little bit to turn the view today. Yeah. So maybe first a little bit, very short introduction of myself. So I'm Martin, I'm from Austria. I was born in Linz, in the northern part of Austria a long time ago. I'm geographer from education, so I did all my education in geography from the, well, diploma studies to the PhD and habilitation, and I studied in Innsbruck, which some of you probably know for skiing and things like that. Then I spent a very long time in Vienna, actually 11 years in Vienna to do my postdoc, and then I changed to the University of Graz, where I'm now full professor for physical geography. What am I working about? So, well, physical geography in general. So I'm interested in many topics actually of physical geography, but with a focus on natural hazards. And as you can see on the picture of the Himalayas, especially on high mountain areas. And what I'm doing is, landslide modeling in principle. So I have developed a model for the dynamic of complex landslides, process chains, glacial lake outburst floods, and things like that. But recently I've changed a little bit, or let's say extended my focus to science communication. And what I'm also doing at the moment, or trying to do, is to create, let's say, a rather big physical geography game for geo-education, mainly for students, but also for broader target groups. And I'm leading the Cascade research group on mountain processes and mountain hazards at the Department of Geography and Regional Science at the University of Graz. And yeah, so I would say let's start into our topic. And if you see, when you see this picture here, yeah, so you can reflect by yourself what was the first thing which was catching your eye in this picture. Yeah, was it rather the volcano in the background, or were it rather the animals, these llamas in the foreground? And actually, I would guess that many of you first actually realized the llamas, yeah, so the animals, and that's actually something which is a little bit of geomorphologists' problem. Yeah, I sometimes in presentations I ask the question, what is a nightmare of the leaders of geomorphological excursions with students? And of course, there are many bad things which can happen, but one of the nightmares is that animals show up, yes, because they will take away all the attention from geomorphic processes, yeah? And that in general is a little bit, let's say a problem or a challenge for geomorphology and maybe geosciences in general, because public interest in nature is still very much centered on biodiversity and related concepts, particularly, of course, on cute looking animals. And that's, of course, also something very human. Everybody knows about biodiversity. There are actually quite few people, probably not among you, but among the general public, who know about geodiversity. Yeah. Also, most instruments to protect nature rather target biodiversity than geodiversity, even though there are more and more exceptions from the rule. And also in order, let's say, to transport topics of climate change, for example, very often animals are used to, let's say, to enhance public awareness. Here we have some kind of poster of Greenpeace, for example, which I photographed in Graz. So glacier retreat, but the polar bear is used to transport the message of polar retreat. Yeah. And so actually the question, so the key question guiding through today's presentation will be, how can we create more public awareness of geomorphic processes? Yes. And in order to tackle this question, let's maybe first have a short look at the concepts which exist in biology or in ecology. And a very, very central concept there are ecosystem services. Yeah. So services which ecosystems provide to society. So that's a concept going beyond actually, or something different than nature protection. Yeah, because nature protection is to protect the nature from humans, let's say, but ecosystem services are rather about which services can ecosystems provide to humans. So these two concepts are of course related, but they have a different scope and different target actually. And there are different types of ecosystem services, from provisioning services, for example, timber, as shown in this picture on the upper left, or regulatory services, for example, pollination by insects, but also very importantly, cultural services, for example, for environmental education, but also for religious purposes and things like that. Yeah. So there is a broad array actually of different types of ecosystem services. Yeah? And of course, the concept of ecosystem services is quite comprehensive. It includes systems where also the non-biotic, the abiotic components are important. Yes. For example, societal importance of glaciers, rivers, and so on. Yeah. They are also to some extent included in the concept of ecosystem services, but usually not at the most central elements. Yeah. The most central elements are rather targeting at biological resources. Yeah. And what I did actually various times, but I last updated it yesterday, is to do a Google Scholar search for certain terms. So looking for biodiversity yesterday yielded 3,850,000 hits in Google Scholar. Geodiversity, it was 23,400. Yeah. So you can also see this in equilibrium, yeah, between biodiversity and geodiversity. Even though, of course, the concepts are quite much intermingled, and it becomes even more extreme when we go to ecosystem services and geosystem services. Yeah, almost 2 million entries for ecosystem services and less than 1,000 entries for geosystem services. But of course, still increasing awareness or importance of geosystem services. And there are actually, yeah, more and more concepts targeting geo resources, let's say, or geo concepts, like natural monuments or nature parks, World Heritage Sites, biosphere reserves. They include biotic and abiotic phenomena, but there are also concepts which really center on geo resources, yeah, which are, for example, a term geoethics, for example, is more and more used, which is ethics related to modifications of the Earth system. There is, of course, geodiversity, which is the diversity of rocks, landforms, or whatever. Geoheritage, so the geomorphological or geological heritage of an area. And also a protection concept is the UNESCO Global Geopark, which is a protected area targeting geoheritage, but also cultural heritage connected to that geoheritage, for example, related to mining activities. So there are concepts, yeah, we can build on to make, let's say, geomorphology more public. Yeah, just to show some examples to illustrate. So these would be two very nice areas of high geodiversity with different types of landforms, different types of rocks, which have evolved in different ways and are also used for different purposes by society. Yeah. So geodiversity, I think it's quite clear what is meant with that. It becomes a little bit more complicated when we move on to geosystem services. Yeah. And what is quite clear, I think, is that geomorphology is in charge to better sell geomorphologic phenomena, as, for example, geosystem services, in order to increase the awareness for such phenomena, yes, as it is done by biologists, ecologists with the ecosystem services. Yeah. So the term geosystem service, I think it was quite unknown 20 years ago or so. It has increased in use a little bit within the last 10, 15 years or so, but there is not yet one single definition, but it's defined in different ways. Yeah. For example, mining would be very clearly some kind of geosystem service, or let's say the ores which are available for mining, but it's more complicated. So on the one hand, we have biodiversity, which are connected to ecosystem services. And then we have geodiversity, yeah, diversity of minerals, rocks, soils, landforms, whatever, which are, on the one hand, of course, contributing to ecosystem services, but also to geosystem services. And in principle, there are two basic definitions for geosystem services. So on the one hand, we can define geosystem services as all services associated with geodiversity, but which are independent of interactions with biotic nature. Yeah. On the other hand, there is a definition which says it's just subsurface services, mainly related to mining activities. Yeah. So for us today, this first definition will be the important one. Yeah, because it includes also landslides and related processes and many different geomorphological processes. Yeah, which can provide geosystem services. And there is indeed a very broad array of geosystem services. Yeah, if we take the concept of ecosystem services and put it onto geosystem services, so we have, for example, provisioning services. Yeah, for example, rivers. Yeah, they provide society with a lot of services. It might be hydropower, but also different types of minerals, and the rivers even do the work of sorting these minerals. Yeah. In different grain sizes, for example, so that they can be used for different purposes. That would be just one example of a provisioning geosystem service. But there are also very important cultural services. Yeah, for example, for touristic use, or also for identity for people, like the Matterhorn in Switzerland. Yeah, so that's a very important cultural geosystem service. It provides a very important cultural geosystem service. Also on the right side, this image, that's actually already something like a small rock fall, probably triggered by thermal weathering. And this is at Uluru, so the former Ayers Rock in Australia. And this serves as a very important religious site. Yeah, so also this provides a quite essential geosystem service to the local society. And actually, I could continue with this list very long. So there are many examples. For example, karst system would be regulatory services for controlling water quality and things like that. Yeah. So many examples. And of course, we can put this a little bit more also into a system with the provisioning services, cultural services, and regulatory services. But there is actually one thing, both with ecosystem services and with geosystem services, which is usually excluded, and these are negative services, in quotes, or disservices, or geosystem costs. We might call it in different ways, but usually disservices is used. Yeah, so that would be negative effects of, in this case, geological phenomena, like damage to infrastructure, fatalities, obstacles to construction and transport. Yeah, but they are usually not included, yeah, in the concept. In my opinion, it would be very important to include them into the concept of geosystem services, because then we could get a more comprehensive view and a more comprehensive concept on positive and also negative effects different processes have on society. Yeah, so including such disservices could provide a more comprehensive insight. I think that's a quite important aspect. Let me show you some examples, and maybe not starting with landslides. So I will move on to landslides in a minute. But we can also have a look at volcanic processes. Yeah. So volcanic processes are maybe those processes in geomorphology which are most interesting to a broader public because they're quite spectacular sometimes. They pose important hazards, but they also provide quite a lot of geosystem services. So this is an example from Iceland, from the Westman Islands, and there is the volcano Eldfjall. And this Eldfjall, it formed in 1973 through an eruption which produced a lava field. So this lava field had, or the eruption, the lava flows had negative effects because they were destroying a lot of buildings actually, and people had to find new homes. But it also provided quite some services. Yeah, so maybe not so much in this case. Fertile land, of course, is important in terms with volcanoes, but in this case maybe not so important. But for example, for touristic use, yeah, you also know from the examples of earlier of recent eruptions like La Palma or also in southwestern Iceland. So volcanic eruptions draw the attention of tourists, yeah, but also, for example, geothermal energy for heating. Yeah, so the lava provided geothermal energy for decades to the people on this island. In this specific case, but that's a very special case, also the harbor of the island became better accessible. Yeah, because the lava flow did not completely close the harbor entrance, but it made it narrower so that it was more protected, or is now still more protected from the waves in the open sea. Yeah, so also a geosystem service. But what is maybe one of the most important geosystem service of volcanic processes, but also other processes, is that it can be seen as an offer for geoeducation. So as an offer to foster awareness and knowledge about geomorphological processes. And this is some kind of concept or some kind of idea we can also transfer to landslide processes. So in principle, landslides are geomorphological processes which might occur naturally or also influenced by humans, which can potentially result in damage and unfortunately even fatalities. Yeah, so this picture shown here from Colombia near Medellin. So this caused some fatalities. Yeah, it was a rapidly occurring process which destroyed part of a house with people inside. So therefore, landslides are usually strongly negatively connotated in society. Of course, landslide researchers like landslides and some media too, because they have something to report. But in most of society, landslides are associated negatively. But I think it's also quite clear that landslides contribute to geodiversity. Yeah, if we have a look at this picture, so I think there is no doubt that the geodiversity has increased due to the occurrence of this landslide. Yeah, even though it had very negative consequences, but geodiversity has increased. And now we can try to find actually some positive aspects of landslides in terms of geosystem services. They can, for example, provide habitats for living organisms. Yeah, then that's again, of course, on the interface with ecosystem services actually. So it's maybe some kind of geosystem triggered ecosystem service, but they can, as cultural services, they can serve as a subject to education and research, and there would be also some other examples. But of course, there are also a lot of disservices, yeah, like damage to infrastructure, fatalities, obstacles to construction and transport. Yeah, so with landslides, we can actually very well see this field of tension between positive effects and negative effects. So this provision of habitats to plants and animals is actually very important. So as I said, as an interface to ecosystem service, so that's maybe rather even an ecosystem service which is provided by landslides. So here are two examples of large landslides in Austria, one historic one and one prehistoric one, which host rare plants and animals, and also very special ecological niches because it's rather dry, coarse blocks and so on, so that special ecosystems can develop like this very small pine forest in the Tyrol on the right side, in the picture on the right side. Yeah, and also they are quite unsuitable for intensive management and therefore in a near natural state. Yeah, so that would be some kind of positive aspect if we rate that positively of landslides. But in many cases, actually, so the geodiversity and also the, if we want to call it that way, geoheritage, which is created by landslides, is undesired by society. So what you can see in this picture is actually, it is the deposition area of a large rock avalanche, which happened in Italy in 1987. So actually for geomorphologists, this was, of course, it was a very interesting situation, landslide deposit and so on. But of course, it was undesired by society. So it was completely remodeled, yeah, with a very straight river through it and a terrace landscape, which is geomorphologically not interesting. But of course, by most part of society, it's a rather desired state, yeah. So there is also undesired geoheritage, which is often removed, yeah. But there are also cases where geoheritage in relation to landslides and also other dangerous hazardous processes is conserved. So in the upper picture we have an example from the city of Beichuan in China, which was completely destroyed by the Wenchuan earthquake 2008 and related landslides. And here, so these the ruins still exist and they're accessible to the public in order to learn something about these processes. So this could be considered some kind of cultural geosystem service. And the same is with Plymouth in Montserrat, which was destroyed also by volcanic processes, or the small town in Graz, Italy, on a hilltop, which was also made uninhabitable by humans due to landslides. Yeah, so the relicts, yes, of formerly inhabited areas destroyed by landslides, they are sometimes used for geoeducation, and this could also be considered as some kind of geosystem service provided by landslides. Yeah, conservation of geoheritage, whether desired or undesired, of course, can in many cases be done on site, but this is not always possible. Yeah, if we, for example, have a look at climate change induced glacier recession, yeah, so this is something we can only avoid if we stop climate change, yeah, which is quite challenging, as we all know. So conditions of glaciers are snapshots, yeah. So therefore, archiving of information, yeah. For instance, if you take a photo every year of a glacier, is very important, yeah. So just as an example, so these are two glaciers in southern Patagonia, 2006, 2016, and 2018. So with very clear differences in the state of the glaciers, and also especially on the left side in the associated geomorphic processes. Yeah. So this type of photo documentation is also, it's a very important thing to conserve geoheritage. Yeah. So always take photos when you see something which is geomorphologically interesting, because you can contribute the conservation of geoheritage. Yeah. So that's quite important. And in fact, in order to make many people aware of these processes and to contribute in some way to conserve geoheritage, of course, public awareness of this type of processes has to be increased. And now, as I said before, so maybe the publicly most interesting geomorphological processes are volcanic processes. Yes. So I hope you can still hear me. So the question is, what do animals and active volcanoes have in common? Actually, something is moving, yes? And if something is moving, this generates attention, and many geomorphologic processes occur over a long time and are often not directly visible, yeah? So it's not so easy, yeah, to observe them. And now the question is, what can be done to generate interest for slower processes? Yeah? So if you didn't hear me because the noise of the volcano was too loud, So I was asking what we can actually do to make also other processes of the, let's say, of the abiotic nature more interesting for people, and actually that's to accelerate processes. Yeah. For example, if we have a look at this, that's not geomorphology, but that's rather meteorology. But for example, this cloud formation and cloud dissipation by Föhn effects, if we accelerate it by 10 times or so, or 100 times, it becomes much more interesting for people because they can see something moving. Yeah, and seeing something moving is a quite important thing. And of course, this can also be done with glaciers. So we have actually a small unfinanced project running where we observe one Austrian glacier with an automatic camera, which is positioned there now for 5 years, and it takes a photo every hour. Yeah. And so we can see very impressively and very clearly the retreat of the glacier. If you're standing in front of a glacier, you will not see that. Yeah. The glacier looks very stable, but if you observe it over a longer time with this time lapse, so you can see very impressively how it recedes. And of course, this is also something which is very important to show these things publicly, yeah, to create awareness and interest for geomorphological processes. But it's not possible in all cases to make series of photos or so, or videos. In some cases, you need models to let's say, to show geomorphological processes in a way which is interesting for broader society. Now there is the statement by George Fox, which is quite a famous statement, that all models are wrong, but some models are useful for some purposes. And this statement is actually true, yes, as long as we assume the existence of some kind of objective reality, yeah, because models are always some kind of generalization, so they cannot represent the whole complexity of nature or society. So they are not really true usually. But if we rather consider the perception, or let's say truth in quotes, in the minds of people, yeah, we can look from another perspective to the results of models of geomorphological processes, yeah, because these models, they can trigger feelings of safety or danger. Yeah, if you have a house, for example, and you see animation or visualization of a model which of a landslide which is hitting that house, of course you can feel unwell, I would say, because this can give you a subjective feeling of danger, independently of whether this model is realistic or not. Yeah. So actually you can use models to manipulate people, of course, but you can also use models to better communicate complex phenomena and to create interest for certain topics. And this includes landslide processes and also, of course, other geomorphological processes. So when it comes to communication and education, geoeducation, so the question is whether models can help us to use landslide processes as cultural geosystem services, yeah, for education. And I'd like to explore this a little bit further. And actually, what we have to define a little bit is the ingredients we need for such a model representation to make it interesting. And I've just provided some keywords here. So motion is very important. So as I showed before, so something has to move in order to make it interesting for people. But also interaction. Yeah, it's very good if you can do something by yourself. Yeah, to maybe to contribute to some process. Also, to have some gaming challenge or so is also quite useful for making things interesting, because then people feel also directly involved, and also immersion, that you feel that you are in the middle of something. That's also a quite let's say a good strategy to make things interesting, and all this creates emotion. Yeah, and let's go a little bit through these individual points, and let's start with the motion. Yeah. So if you make, let's say, nice 3D animations of geomorphological processes, so here we don't have a glacier, so this we don't have a landslide, so this is a rock glacier, and if you make it moving through a model, then it looks much more interesting, yes, than if we just see this the still image. And this is a pure model. Yeah, this is a pure model where the orthophoto on top of the elevation model was also distorted so that it looks more or less realistic. And you see this slow deformation of this rock glacier in Austria. Yeah, but you can do it also, of course, with large landslide processes. So this would be the Köfels landslide in Austria, in the Tyrol. So the largest landslide which is known in Austria. It happened almost 10,000 years ago, and it has a volume of 4 cubic kilometers, and you can let it move in order to give people some impression how these processes can work. Yeah, and actually I could show you many examples of this, because I'm working a lot of these things, but maybe 2 more examples. So one of a very recent event, actually, so of the Platten event, so the Nesthorn-Birch-Gletscher collapse in Switzerland, which happened in May this year. And actually these processes happen in 2 stages. I will now start the simulation. So first of all, so there was actually a series of rock falls onto the glacier surface. So this is a generic representation. So it's just showing a schematic view actually of these happenings. And then there was the load on the glacier, and then the glacier collapsed and moved down valley very quickly as some ice rock avalanche, completely or almost completely destroying the village of Platten. Yeah. So this is also a possibility to show, to communicate recent events. And yeah, as many of you, I think, are maybe more interested in coasts or in coastal areas than in mountains, I also have an example of a tsunami. So the Anak Krakatau collapse of 2018 in Indonesia, where volcanic slope collapsed and rushed into the ocean, triggering actually quite a fatal tsunami, is shown here in this example. Yeah. So with models, you can do many things actually to make things moving and to create interest and maybe enthusiasm in people for such geomorphological processes. But motion is not everything. Yeah, it might be a little bit boring actually to watch too many of these animations, and we need other things. Yeah, maybe 2 more examples with motion. So of course, if it becomes more realistic, then it's even more important. So here we have a very realistic approach to view a snow avalanche, and the same can be done for the Bayonne landslide of 1963, where a landslide was rushing into a reservoir, and this reservoir was spilling over. Yeah. So as I said, I could show you endlessly these things, but in fact, motion is not everything. So another thing which would be quite important, an important ingredient, would be interaction, so that people can do something by themselves. So this would be a very much simplified representation of the volcanic crisis in Montserrat at Soufrière Hills volcano. And here, for example, so this is something I did for my students. So just clicking onto this point, you can create your own lava dome. Yes. And then you can go further, and then you can click on the lava dome to see what happens if the dome becomes unstable. Then we have pyroclastic flows. Yeah. So in this case, it's the student or whoever who is triggering the pyroclastic flow. And then when going further, we have the pyroclastic flow deposits, and then let's let it rain. And then we have lahar flows, which transport that material farther downwards. Yeah. So this would be, here also we have the motion, but here represented in a simpler way, but also interaction. And then there is the challenge, which should also be a quite important ingredient. And what I show you here is the so-called Moore game. So it means debris flow game. It's a game which was developed in Switzerland, where you have to plan your village in a mountain area. And then the debris flow comes, which is simulated with a real simulation software. And then you will see whether you have well planned your village or whether there is a lot of damage due to the debris flow. Yeah. So this gaming challenge is also something which is quite important to expose people to, if you would like to make them interested in the processes. Yeah. Because also, like with the interaction and even more, they feel involved. Yeah. And finally, we have the immersion. Yeah. So that people feel that they're inside the whole scene. And for this, we can nowadays use virtual reality. Yeah. So when talking about virtual reality, so we can talk about different levels of virtual reality we can use. So actually the lowest level, so I called it level 0 here, would just be these 3D animations I showed you now. So that's not actually not real virtual reality. That's yeah, rather something relatively simple, but I still listed it. But if you would like to get immersed in some process, one more important thing is that you can really see it in 3D. And for this perception in 3D, there are different possibilities. For example, there is the anaglyph view. Yeah, probably all of you know those kind of glasses with one red and one cyan glass. Yeah, and you can see things in 3D if they are made for that. Yeah, so that would be a very simple and a very cheap method to see things in 3D. If you would like to do it a little bit more in more advanced way and feel even more immersed in the thing, you can do some kind of virtual reality scene inspection, yeah, where you use a real headset, virtual reality headset, and then you can feel that you're in the landslide and you can move around, view it from different perspective in order to get a very real feeling what happens. And this can also then be connected with sound and things like that. Yeah. And those levels 4 and 5 here, they would even go one step further. So that would be development of real computer games, serious games, where landslides occur, where you can interact in different way, maybe try to prevent landslides, or maybe try to run away, for example, from landslides with different speeds and things like that. Yeah, in order really to get a real impression, to get involved, to get interested, and also, of course, to increase awareness, yeah, for this type of processes. So this would show actually how you look like if you apply the different levels of virtual reality. So the level 0, you need nothing in principle. Levels 1 and 2, you need this, or level 1, you need this kind of anaglyph glasses, and with level 3 and higher, you need a real virtual reality headset, which looks quite funny, yeah. And with this one, you are really immersed in the scene. And this is actually what we are doing at our institute, or in my working group at the moment. So we try to develop some simple, but even in the meantime, some not so simple virtual reality applications for geoeducation, focusing on landslides. And also we exposed school children to these experiences, and yeah, the results were promising. So those school children exposed to the experience showed a little bit, let's say, better knowledge about the processes afterwards than before. But yeah, but this thing is a little bit hard to interpret in detail. So we need more studies on this. But of course, these studies are also a little bit difficult from an ethical point of view. Yes, because we allow some school students, we allow an experience which we don't allow to others. So that's a little bit problematic, but we have to find a way to evaluate the effects of these things. So most simple virtual reality applications. So with anaglyph glasses, I have provided you some kind of QR code and also web link, which leads you to a YouTube channel where we provide some simple 3D animations. Some of them you can view in 3D with such type of anaglyph glasses, which are quite cheap. So if you would like to try it, you can just go to this link and then do it. But what we have running at the moment is a project which is called MoveMont, so the moving mountains, which investigates the role of landslides as geosystem services in Austrian UNESCO Global Geoparks, which is funded by the Austrian Academy of Sciences. And what we actually did this year, so we installed a small VR game, virtual reality game, in the museum of one of these geoparks. So the geopark Steirische Eisenwurzen. So there was the opening of this museum experience. So with the mayor, or I think the vice mayor, the deputy mayor of this small village there, who was the first who tried out this landslide virtual reality experience. And as far as we can see it until now, so there is quite positive resonance on this, even though there are not too many people visiting the museum, but still we have some way to evaluate whether this is a thing which is used by people. Yes. So maybe to tell you a little bit about some concepts we applied. Actually, the example I show you now is not the exact thing which was then installed in the museum. It was an earlier idea, which we are also trying to follow. So aim of this, increasing interest and awareness for landslide processes among a broader public by creating a VR environment where people can interact with landslide processes in an exciting and educative way. And what did we do? So landslide simulations of a large landslide with our in-house mass flow simulation framework, which is called Avaflow. It's not so important here. And then we have different software packages like Blender, for example, which is used for, it's a free software which can be used for 3D animations, 3D videos, and also 3D scene inspections in virtual reality. And we also have an interface with Unreal Engine, which is a real game development software, game engine. Yeah. So the Blender interface is fully operational. For example, the Platten simulation I just showed you was made with that one. And the interface with Unreal Engine is something we are working quite intensively at the moment. So this is partly operational, but yeah, some improvements and some further ideas still to be done. So in this geopark, in this UNESCO Global Geopark, there is a very large rock avalanche of almost 1 cubic kilometers, which happened approximately 5,700 to 5,900 years ago. And actually, there were 3 logs recovered from the deposit, and they were used for dendrochronology, so we know how old the landslide is. And so now, idea for the gaming application was that we have some pre-event landscape of the landslide area where the player can move freely. Player triggers the landslide by touching the release area, for example, with a magic wand. Yeah, then the landslide would occur, and then a tree log would appear from the deposit and can be grabbed by the player, and then the tree log tells how it experienced the landslide and the time after the landslide. Yeah, yet it's available in English, German, and Spanish, but it can also be, of course, done in more languages. So this would be some kind of idea, yeah, to make some informative gaming application. As I said, finally, it was not installed because it was a little bit too complicated for the museum designers, yes, but this is still an idea which is, let's say, waiting for realization. In reality, the experience is a little bit simpler, which is now installed in the museum. So, So PowerPoint not reacting. Let's just wait a moment, but presentation anyway is almost finished.
Technical glitches.
Yeah.
It all gone so well, hasn't it?
As long as it's only the PowerPoint and not the internet connection.
No, we can still hear you. It's fine.
Yeah, that's fine. No, I think I will close the PowerPoint and open it again. It should go quite quickly. Excellent. So now PowerPoint is closed. Then let's open it again, and then it should work again in a minute. Should just find it. Here it is. So then let's go.
Cool. Excellent.
Here. Okay. Let's go to the next slide. And can you see something again?
Yeah, it's perfectly clear. Thank you.
Okay, very good. So what are the challenges of this type of VR experience? Of course, one thing is the performance. Yeah. You saw that my PowerPoint presentation actually now collapsed, actually, because even the animation is maybe a little bit much. But if you really look at things in virtual reality, that's very computationally expensive. So you need gaming computers for that. And actually, we are looking at the moment for strategies to make it a little bit more efficient. Yeah. Of course, we would like to do it also for other type of landslides than these flow type landslides. So, for example, object-based rockfall model with physics design and things like that. This is still something to be implemented and tested. I will show you something about it in a minute. And what would also be, of course, very tempting would be to do some kind of multiplayer game. Yeah, where people can also interact with each other, maybe in a collaborative way to decrease landslide risk or things like that. Yeah, but that's rather something for the future. Yeah. At the moment, we are rather working on some also technical challenges. And in fact, I told you before about those game engines. Yes. So so those software for development of computer games, and they have very, very good physics implemented. So for example, for rockfalls, and this is what I show you now. So this would be a rockfall model generated directly in the game engine, Unreal Engine. And this, I think this is something which is very promising and which looks very realistic. So this is one of the first tries, actually. It can be refined very much. So those game engines are very good for also for modeling. And we are working currently on improving these things for better making people aware of geomorphic processes. Yeah. So I already come to my synthesis, if it works. Yeah, it works. Okay, so final slide. So we have landslides, landslide processes, which are certainly a contribution to geodiversity and which can also provide geosystem services, but also disservices. Yeah. In principle, in terms of landslides, there are certainly more disservices, so more negative effects in terms of hazards and risks than positive geosystem services. Yeah. And actually here I have distinguished a little bit between real geosystem services and geosystem triggered ecosystem services, as I called them. Yeah, but in principle it doesn't matter so much. But the important thing is what comes now. Yeah. So we believe that if we use landslides for awareness building, for education, we can increase public awareness of landslide processes, which also puts down a little bit and also decreases those geosystem disservices, because then people can better manage, yes, the related hazards and risks. And this is a little bit, what is our goal? Yes, to reduce or to help reducing landslide hazards and particularly actually risks, yeah, through environmental education. That's it from my side. So thanks a lot for listening, and I will be very happy to answer questions.
Excellent. Thank you, Martin. That was really, really interesting and really nice to have a presentation where it's, you know, it's focused on landslides, but also the concepts are so applicable elsewhere and be so useful, especially with all the, you know, the geomorphology is dynamic anyway, but you know, things will change as we know into the future. So yeah, really, really cracking talk. Thank you. We can open up the floor for questions now. If you'd like to put your hands up or put them in the chat, then please do. But Lily, I can see you've got your hand up, so let's start with you.
I'm doing the typical thing of meeting and then unmuting myself and panicking. Hello, thank you so much. That was absolutely brilliant. Thank you, thank you. So I, as hi everyone. So as lots of people on the call will know, that I am now the landslide and coastal community coordinator for the Isle of Wight. So basically, we're an island with an absolutely huge landslide in the south point. So there's like one of the largest inhabited landslides in Europe is on the south coast of so on Friday I'm going to go into a forum and talk to people who live there about like that kind of thing of how to kind of try and explain to people, like, obviously I can't say, oh, you know, it's okay that your house is sliding into the sea, because it means that all of the tourist beaches around you get sand just in time for the tourist season. So it's that kind of thing of like trying to be a bit more nuanced with how you explain the risks and the benefits, and like that thing about education. So, you know, do you think that all of us people in the room, like not just me, should be kind of like trying to kind of talk and engage with people by, I don't know, going into schools and stuff like that, because like I had a phone call just today by someone on works with me saying, oh, I've got this friend and she absolutely loves this house, but it's in this place which is prone to landsliding. And I'm going, but it's so nice and she can't, you know, even though she knows she shouldn't. Yeah, so that kind of thing around, like, I don't know, how to educate people and how to let them really understand the risks, because it's easy enough to say, oh, you know, like, I understand the risk, and then when your house disappears into the sea, that's quite another matter. So anyway, sorry, I'll stop talking and let you.
Yeah, thanks a lot for this question. Actually, I was hoping for this type of question, because this, of course, is a really, really sensitive topic. Yeah, when it comes to people who are by themselves directly affected, or even if they maybe have lost friends or so in a landslide. Yeah, explaining to them that landslides are something positive or have positive aspects, I would say that's very difficult. And that's actually one of the reasons, yeah, that we work very much with prehistoric events. Yes.
Yeah,
because those prehistoric events, at least in my opinion, are in the way better for environmental education, as nobody was affected by them in a negative way, so people do not have negative associations with them. And they're usually those who are known nowadays are very large, so they're interesting processes, and you can approach them with a little bit more neutral view. Yeah. So you can show the process without interfering with some personal experiences or fears or so much, or it's at least it's easier, let's say, to avoid those topics. Yeah, I think when really working in the management of concrete landslide cases, and to tell people who have a house on a landslide which is threatened sliding into the sea, of course it will be very difficult to tell them, yeah, landslide is something nice. Yeah, so I think I would rather target this kind of initiative at a broader public, not directly at affected people, yeah, in order to generally increase awareness. Because I mean, I would say the large majority of people is not directly affected by landslides and has a little bit, let's say, a more neutral view about them. Yeah, it's always very difficult. Of course, when people are involved, who are directly affected. Yeah, that's the same if you, for example, if you take an example of biology, for example, in Austria, we now have a discussion whether wolves should be shot or not. Yeah, on the one hand, they should be protected. On the other hand, sometimes they're attacking sheep. Yeah, if you're the owner of the sheep, of course you will not be very happy about protecting wolves. Yeah, because it affects you negatively. But in a general broader view, yeah, so the view might be a little bit more open. Yeah, but very sensitive topic.
Yeah, because I was the long as a complete nerd of my island, the longest kind of like running postcard company in the world, I think, is actually from the island. So one of the things that I was looking into was trying to get old postcards to show people how the coast had changed. So I might, kind of think about doing that for the landslide as well, and show kind of like historic landslides to be able to kind of show that this process has always happened. It's only the problem of people getting in the way. But yeah, okay. No, that's fascinating. Thank you.
Thank you.
That's interesting. Yes, absolutely. I definitely think there's something for setting the long-term context of a site. You know, this is what was going on in this environment before people were there, and it sort of makes people think, doesn't it? Like, you know, it actually, you know, maybe we've been a bit bad at planning. It's not just, you know, nature out to spite us. This is just the landform changing, and it's what it does over longer time scales. Yeah, I've got another question in the chat from Uva, asking whether the geosystem disservice could also be an economic service if you have to rebuild the damaged infrastructure. So I guess it's a bit more complicated because there's a chain of other services dependent on those ones as well.
Yeah, but of course, so that's also a very important thing. So of course, if there is, let's say, if there is a large landslide, of course there are economic effects. Yeah, there are negative effects for some, and for sure there are positive effects for others. Yeah, maybe if we take the example of earthquakes, yes, which is maybe a little bit more striking and more large scale often. Of course, the construction industry will profit, yeah, if there are damages, because they have a lot of work to do, and the same is with landslides if they are large enough to really have an impact. Yeah, that's very clear actually, and that's absolutely true to certain actors. Yeah, such processes will always be a service. Yeah, so also for the media, for example, so if they have to report something, so construction firms, the media, yeah, so they will also researchers, yeah, so they will be the winners. Yeah, they will be the winners of some processes, whereas other groups will be the losers. Yeah, there are always winners and losers. Also with climate change, for example, there are winners and losers. So for example, people with doing climate action, so for them climate change is something very positive because they, in principle, they can do something. Yeah, so yeah, but that's actually a quite important point. Yeah, so that that economic possibility for economic activity, yeah, so that might be a very relevant thing for some groups, companies, and so on.
Excellent. Thank you. Well, I think that's all the questions. So we're pretty much at 2 o'clock. So on that note, I think we'll probably wrap it up. And yes, a massive thank you to you, Martin, for spending the time to talk to us today. It was much appreciated. Thank you. It was a really thought-provoking presentation, which hopefully people can share as well with colleagues where relevant. Yeah, well, watch out for the recording. It'll come up on the website soon. And yes, watch out for the next BSG talk in January. It will be advertised, I'm sure, at the beginning of 2026. Excellent. Thank you very much. Bye-bye.
Thank you. Thank you. It was a pleasure. Thank you for listening and discussing. Bye-bye.
Bye-bye.
Thanks.